Okay, let's finish up section 7.4 review for exam 4. It says evaluate each trig function exactly, so that means no decimals. I want the answer to be in fractional form. So tangent of 11 pi over 6. Well, we need to know that tangent of the angle is going to be sine of the angle over 6, and then cosine of the angle. And the sine for 11 pi over 6 is negative 1/2. We're going to divide that by the cosine, which is square root of 3 over 2. Keep, switch, do the reciprocal. So negative 1/2 times 2 over the square root of 3. The 2's reduce. We're left with negative 1 over the square root of 3. If you want to rationalize your denominator for extra points, square root of 3 over square root of 3, and this is equal to negative square root of 3 over 3. Otherwise, this is the correct answer. The next one is secant of pi over 3. Well, secant is going to be 1 over the cosine of pi over 3. So that's going to be 1 divided by, let's look at pi over 3. Cosine is going to be your x value, which is 1/2. So do your keep, switch, flip. 1 times 2 over 1, which is just 2. Everything is positive in quadrant 1. And then the last one up for this one is the cosecant, which is 1 over the sine of the angle. So that's going to be 1 divided by, let's go look at about 4 pi over 3. And we're looking for sine, and sine is my y value, so negative square root of 3 over 2. Keep, switch, take the reciprocal. 1 times negative 2 over the square root of 3 is negative 2 over the square root of 3. Make sure, and this is the correct answer. I'm good with this, but if you want extra bonus points, you can rationalize that denominator and get negative 2 square root of 3 over 3. Okay? Let's look at the next one. It says determine where the function is undefined. So the tangent of theta, where is it undefined? Well, you need to understand that tangent of theta is equal to sine of theta over cosine of theta. To have an undefined fraction, that means your denominator is equaling 0. That means cosine is 0. And where is cosine 0? That means your x value for your ordered pair is 0. Well, it happens at 90 degrees or pi over 2, and it also happens at 270 degrees, 3 pi over 2. So tangent is undefined at 90 degrees, I'm just going to use degrees, and 270 degrees. Okay. What about cosecant of theta? Cosecant of theta is 1 over sine of theta. So when sine of theta is equal to 0, cosecant of theta is undefined. And where is sine? Did I do that wrong? No, I didn't do it wrong. Okay, so that means that over here, your y value, if it is 0, and over here, if your y value is 0, that means your sine is 0. That means your cosecant is going to be undefined. So cosecant's undefined at 0 and 180 degrees. Okay, there we go. Next, if sine of theta is 3/5 and theta is in quadrant 2, find all other trig functions. Well, we've got there's one way I like to do this, and that is using the Pythagorean identity. So if sine of theta, because remember sine squared theta plus cosine squared theta is equal to 1. So I can find cosine just by substituting in 3/5 for my sine. Make sure you square it because that's what this is referencing. And then I get 9. 3 squared is 9, 5 squared is 25. You've got cosine squared theta equal to 1. Subtract 9/25 from both sides. and we get cosine squared theta is equal to, let's turn this 1 into 25 over 25. So then it's 25 minus 9, and that's 16 over 25. The last step for this to find your cosine is to take the square root of both sides. So the cosine of theta, square root of 16 is 4, square root of 25 is 5. So the cosine of theta is 4/5. Okay, there's that one. Then I'm going to come over and do my tangent. Tangent is sine of theta over cosine of theta. And my sine of theta is 3/5. I'm going to divide that by my cosine 4/5. And then I have to do my keep, switch, take the reciprocal, flip it. 3/5 times 5/4. My 5's reduce, and I'm left with 3/4. Okay, let's find our, let's see that sine, cosine, tangent, let's find our cosecant, which is 1 over the sine. And sine is 3/5. Keep, switch, reciprocal. All right, I'm going to highlight where these answers are. Secant is 1 over cosine. Cosine is 4/5, so 1 divided by 4/5. Keep, switch, take the reciprocal. 1 times 5/4, which is 5/4. And then the last one is cotangent, which is cosine over sine. Cosine is 4/5. Oh, it should be divided by. And then 3/5 for sine. Keep, switch, flip. 4/5 times 5/3. 5's are gone. So cotangent is 4/3. Now we're not done. We've only done the fractional portion of it. What we have next is to keep in mind that this angle, they're telling us, is in quadrant 2. So if that's the case, that's 1, 2, 3, and 4. You need to know that everything is positive all is positive in quadrant 1. In quadrant 2, if you forget who's positive in which area, think about your ordered pairs. If you go to the left of the y-axis, your x values are negative, and if you're up above the x-axis, your y values are positive, right? So that means your cosines are negative and your sines are positive, all right? So we're living in quadrant 2. Our cosine is negative, so that means I need to put negative for my cosine and negative for my secant. So make sure you don't forget those two for sure. The other two, the only things that are positive are sine and cosecant. All right, that's the only things that are going to be positive. Tangent's going to be negative, as well as cotangent. There's only going to be 2 for each quadrant, except for quadrant 1. Down here, it's only tangent and cotangent because they are both negative for sine and cosine. And then over here, you've got positive for your cosine and negative for your sine. So that means you've got sine and cosecant are positive here, tangent and cotangent are positive here, and then cosine and secant are positive in quadrant 4. And there you go. Let me know what questions you have regarding that. The next one, we're going to use the Pythagorean identity. It looks like. It says use the Pythagorean identity to verify that tangent squared theta is equal to plus 1 is equal to secant squared theta. Well, I haven't prepared this, so let me see if I can figure this out. Well, sine over cosine is tangent, so I'm going to say this is sine squared theta over cosine squared theta. And secant squared theta is the same thing as 1 over the cosine squared theta. Okay, well, I can go through and make sure that we have the same denominator. So this 1 I'm going to make as And this is trial and error for me. I haven't done this yet. So cosine squared theta over cosine squared theta. Okay. I'm going to bring this one down. All right. So now, I'm going to come up here. Sine squared theta plus cosine squared theta. Because these are the same denominators, I can add them. Sine squared theta plus cosine squared theta. That's equal to 1 because that is my Pythagorean identity. So 1 over cosine squared theta. And they are both equal to secant squared theta. Okay? All right. The next one is evaluate exactly. Cotangent of 7 pi over 6. Well, cotangent is going to be cosine of theta over sine theta. So we're going to use cosine of 7 pi over 6 over sine of 7 pi over 6. I don't expect you to write all of this. Now up here, you're going to need to show me that you understand how you get to the fact that it is equal to secant squared theta. Down here, you could have skipped this step or this one. It doesn't matter. Cosine of 7 pi over 6 is my x value for 7 pi over 6, which is negative square root of 3 over 2. Divide that by my sine, which is 1/2. Sorry, it's negative 1/2. Everything's negative down there. Keep, switch, take the reciprocal. Negative square root of 3 over 2 times negative 2 over 1. My 2's are gone. I'm left with negative times a negative, which is a positive, square root of 3. The next one is secant of 5 pi over 4. Secant is 1 over cosine of 5 pi over 4, which is 1 divided by, look at your 5 pi over 4, find your x value. Okay. Negative square root of 2 over 2. Keep, switch, reciprocal. Negative 2 over the square root of 2, which is negative 2 over the square root of 2. This should be a multiplying sign. I'm going too fast. Sorry about that, y'all. All right, and this is holy, I need more coffee. So the last part of this is, if you want to, this is the correct answer, negative 2 over the square root of 2. But if you want to rationalize it, you can just multiply by square root of 2 over the square root of 2. And this becomes negative 2 square root of 2 over 2. Hold the phone. You can reduce this. We can reduce this, right? Because if we multiply by that, we get 2 square root of 2. This becomes square root of 4, which is 2. These reduce, and you're left with negative square root of 2 if you rationalize that. So be careful. Extra credit opportunities. Before you start your exam, you can fill out a blank unit circle. You do not have to. This is strictly your option. Hold on. Do not take a long period of time to do this unit circle, because then you're eating into your exam time. The other thing you can do is to rationalize those denominators if there's a square root in them. Those will get you extra points as well. Okay. If you decide not to fill out your blank circle, that's fine. You'll have another chance before the final exam as well. Okay. And as well as rationalizing the denominator on the final exam for your trig functions, that too will get you extra points. All right. We'll see you in class. Let me know what questions you have.